parallel reaction. A giving B and C, this is nothing but K1, this is nothing but B2. So for this, let us assume A to B and B to C. Sorry, A to B and A to C. Both are first order reaction. Means rate of formation of the product will be at any time T is dx by dt is equal to, let's say, dy by dt plus dz by, what is this? This is nothing but, let's say, this is nothing but rate of formation of B. This is nothing but rate of formation of C. Okay, we can also write, means dx by dt is equal to k1 into a minus x plus k2 into x. X is the, note it down, x is the total sum of the total B and C, how much amount is there, that is nothing but the x. If you integrate this, we'll be getting ln a by a minus x is equal to k1 into k. This is the rate equation. This is the case. Always remember this. Normal, this is like a normal first order reaction. What will happen? Ln a by a minus x or a0 by a t is nothing but kt. Here it is k1 plus k2. This is very easy. But remaining previous two is little bit critical to remember. But you should remember. There is no way. I cannot help. But see, the reason is the question has come, so I could have avoided that. No other way. Okay. T half will be like first order reaction 0.693 divided by A will be, let's say, concentration of A. Concentration of A, I meant that AT will be, remember, A0 e to the power minus KT. This is the case, right? It happens like for the first order, right? So this will change to K1 considering why it is happening. This is the way how we are considering the same thing. A is becoming K1 B, K2 C. So dA we write now that from there this is at time t is equal to 0. It is concentration is A0. At time t it will be concentration is. From there we got earlier case what happened? Remember first order AT is equal to A0 into to the power minus KT. Here K is nothing but K1 plus K2. This is the difference. Another thing I'll tell you, I'm writing on the right side. Note it down. Amount of B at any time t divided by amount of C at any time t will be always a constant. Amount of B at any time t, amount of C at any time t will be always a constant. Just remember this. Okay. On the next is chain reaction, but chain reaction they haven't given any questions so far. Okay, but I will tell you just few things just for by any chance they provide. We don't know. They have not given question on chain reaction. Let's say ozone decomposition. What happens? Ozone decomposition reaction is 3O2. Sorry, not 3O2. Twice O3 giving. This is the overall reaction. But how it happens? Let's say O3 plus nascent oxygen. This O3 again reacting with the oxygen giving. The overall reaction is this is K1. If you put steady state approximation a lot of things, you will be getting rate of ozone decomposition d of O3 divided by dt will be coming. Lot of C. I'll show you. Overall calculation is this much. Okay, not required. So just remember This is the overall equation. This is K1, K3 into O3 square, K2 into O2 plus K3 into O3. Another condition can be written as if K2 O2 is very greater than K3 O3, then this will become is K3, K1, K3, O3 square divided by K2, nothing but new constant K dash, O3 square divided by, this is a new constant K dash. Divided by O2. Because O2 is there, na? This is total is coming K dash. That means what is the significance? Significance line, you note it down. This is significant line. What we get it? Significant line is this. As mode and mode product is what? O2 is formed rate of ozone decomposition as more and more product. See, look at this. Minus, this is O3 is what is coming. O2 is increasing. O2 is in the denominator. If O2 is increasing, rate is also decrease. That's what, as more and more product is formed, rate of ozone decomposition decreases. Understood? This is the significance of this. Question will, if the question comes, they'll ask you, if the more product is forming, what is the rate of the decomposition? You should be always remember it will be decreasing. Another is formation of phosgene, I'll tell you. Also important, but only remember the final equation as I'm discussing. Okay, no need to go for any other. For this, if you don't want to remember the rate of ozone decomposition, no problem. Just remember the last line, what I told you, and the steps. No need to go for these things because no one has asked question on that. So if by any chance they ask question, that's what I'm telling you. Okay, this is the case. We calculate fire using the steady state approximation. If something is the reaction is going, producing, and again it is going away, we use the steady state approximation. From there we get it, the equation, everything. Another is, next is this. Formation of phosgene. This is phosgene. This is the overall reaction. Stepwise. So this is the overall rate equation. If you apply steady state approximation, you'll be getting. This is your answer. K dash into CO into Cl2. Cl2 to the power half, and so there is half plus 1. Order is 3/2. Understood this kind of cases, but no problem. Just remember this. What is the final equation? It has to go via the steady state approximation. Lot of things are there, not required. Just remember the even if you don't want to remember the steps, no problem. But remember the what is the final. Chlorine to the power half. That means rate of formation of the phosgene depends on inverse proportional to the chlorine concentration to the power half. And or CO concentration to the power 1. That is most important. And so this is also very important part. Let's see how far we can go. Next class, tomorrow class is there, right? We can discuss from this part. We have to go. There are 3 isotherms are there: Langmuir, Freundlich, and you also have Bate isotherm. On that note, they have asked question: Langmuir, Bate, Freundlich isotherm. Absorption, surface chemistry part is there, na? We forgot all this. You haven't read that part? Okay, that is very, very important, crucial. That is nothing but heterogeneous catalysis part, heterogeneous gas solid reactions. There are 3 isotherms are there. We'll discuss tomorrow. Okay, catalyst is there are chemical kinetics means I'll discuss kinetics, enzyme catalysis, also isotherms. That is complete 3 chapter combination. Okay, question has come every year. That is very, very crucial part. So I'm telling you. Next is remember that it from the Arrhenius. What is Arrhenius equation? A double R H. Arrhenius equation is, it has been observed that this is the equation. Remember, K is equal to A e to the power minus A. This is from the childhood, you already know this. What is A? A is called the pre-expo factor. EA is equal to, EA is the activation energy. R universal gas constant, and T is nothing but the temperature in K. What is K? Rate constant. If I put ln K, log K, also remember like the formula can be also written like T ln K, also remember like this. Let me plot this, then I'll write it. T ln K divided by dt is equal to K by not K, is equal to, it will be EA by R. D ln K by dt is equal to EA by R. Formula can be written like this. Use this formula, otherwise use this, anything, whatever they wanted to, everything. These are the all our formulas. This is nothing but what? This what shows? y is equal to c plus mx type. If I plot, let's say, shall I plot it here? I can plot it. ln k versus 1 by t. This is the ln k. Y is equal to c plus mx. So what is c? C is the intercept. What is the intercept? ln a. What is the slope? M is the slope. Minus EA by. B exponential factor, another name is, there is also called Arrhenius factor. That's another name. Another name is Arrhenius factor. Also can be written as, there are three names: frequency, another equation from them has been evolved using this formula. That is, I think you have already know this formula. So what are the chapters you know, Sapna? You read what are the chapters? No, I'm not talking about physical science. Previously in the college, equilibrium, thermodynamics, gas, no, solid state. Only this, all those remaining polymer, nothing they have taught.
Polymer, I got it. Organic.
Not all polymer, organic, not this part of physical part. Mass average molar mass, number average molar mass, Z average molar mass. All question has come every year. I'll show you the question.
I had only physical in one semester, so.
They're not basic.
BSc, I didn't anything.
These are all at BSc level. ln K2 by K1 will be minus of EA by R 1 minus if I take a minus common 1 by T2 minus 1 by or if you want the formula in this log another is very important, unit of A. What is the unit of A? You look at this from this equation. We know K is equal to e to the power K is equal to A e to the power minus EA by R, right? But we also know that what, you know, this is unitless part. E to the power anything will be unitless. That means unit of K A will be nothing but, so for the first order reaction, it will be second inverse. Whatever the unit of A, that will be the unit of K. Always remember. A few things. This is the very easy. It is the reaction coordinate, or can be drawn with, this is same coordinate, reaction coordinate or reaction progress. If I plot with respect to the energy, potential energy or potential energy, whatever you draw, POT means potential energy. Okay, if you draw this, you'll be getting, if this is reactant, this is product, right? This is the activation energy, right? This is the difference. What you can see the difference. This is the reactant. This is the difference. What you can see here, nothing but called the drainage. Drainage is always, this is the difference will be the activation. What is drainage? Always remember activation energy for the forward minus forward reaction, sorry, for the forward reaction minus activation energy for the this is the here is the activation energy. Another you remember, EA can never be negative. EA cannot be negative, but EA can be zero. EA can never be negative. The reason is all. What is the reason? The reason is all the reactants has to convert into products. All the reaction has to be converted into products. Activation energy cannot be negative. Activation energy zero, for example, for a radical reaction. They don't need activation. I mean, there are so much active, they don't need any energy, particular energy. That is for radical activation energy is zero. Because radicals are highly reactive species. They don't need any activation, further activation energy to form the product, participate in the reaction or form the product. Means for EA cannot be, EA is always positive or EA can be zero, but EA can never be negative. Just remember these things. 1 minute. The time. Oh. So collision theory, there is also collision theory is there, na? But no one has ever asked question on the collision theory. So better you can skip the part. Because some part don't need. If question didn't come anytime, I don't think so they'll suddenly give the question from this. Collision theory, they have never asked questions. So better you can remember, don't collision theory is not required. If I find any question, I'll let you. Otherwise, not required as. Lindemann, not in term. This is for the unimolecular so what is the case? He suggested A reacting with A giving activation of the molecule A star plus. This is the K1. This is the activation state. A star again reacting with A providing A plus. This is nothing but called the deactivation state. This is K2. So we can write A star is equal to A star the product. This is the product formations. Noting down this one. PP, this is product is dt will be always K3 into concentration of according to the normal A star. The rate equation. What is A star? A star, if you put it, it will be coming. I'm telling you directly writing K3, K1 to A square divided by. I'm not doing anything. I'm not showing the steps. I'm directly going there. Not required steps for you all you guys. K2A this is your final. There are two cases are there which I'll discuss in the next class and then not today only and then we'll go to the next class. We'll start with the catalysis. And catalysis, homogeneous catalysis, they have asked question, heterogeneous catalysis, not that much question has been asked and all those things. So I'll tell you what is important, okay? Note it down. There are two cases are there. This is actually rate of formation of so case one, when the product formation is more significant, then that is product formation is more significant. That means time lag is very small. No time. Product formation is more significant. Then time lag will be very short term. Product formation is very strong. That means K3 is very, very greater than K2. What I say? K3 is very, very greater than K2. Product formation is more important. Then we can write, that means K3 plus K2A nearly equal to K3. So the equation becomes dP divided by dt K1 into K3 into A square divided by nothing but K1 into. This is the second order. Case number 2. What is the case number 2? When the deactivation is more significant, that means more significant means which step? Deactivation is more significant. That means we can also write K2A is very, very greater than K3. We can also write dP dt K3 K1 A square divided by K2 into nothing but K3 K1 K2 into that means this with respect to this is this is K dash. A, there is nothing but A, power is 1, that is the first order. Or is K2A is more, right? You put the, check the equation. In that only I put the value. Last. K3 I'm not putting because K3 is more than that. K2A is really greater than that. It is nothing but equal to K2A. I put this. A is going away, nothing but becoming first order. Understood? This is the total thing.
But there K3 K1 A whole square.
Divided by K2A. So A going away, right? Understood? When the deactivation step is more significant, that means time lag. If you want, you can note it down here. Time lag is more. Time lag is which color I'll show. 1 minute. Time lag is so I'm sending this, downloading it. So chemical kinetics is not part of this. Now chemical, whatever we have discussed, chemical kinetics is done. You have there are 3 parts. I said that next part is catalysis. Then next part is enzyme catalysis. These are 3 are there. In the data also isoforms are there. That is very, very important. I'll discuss them. We need to be very fast. So many things has to be covered up. Okay, so I'm ending the session here. Tomorrow we'll discuss from here. What time the class is tomorrow? 12:30. Then break 2 to 4. So I'm ending the session. Memorize by heart whatever you want to do the form. Please, whatever the final equation, remember this. I'm telling you.